Hello everybody. Today we're going to be going through solving the Leetcode problem, squares of a sorted array. And this one's an easy question. I think the tags were array, two-pointer, and if I'm not mistaken, that's those two on the top of my head. And this is the problem. So basically we're given an integer array nums, sorted in non-decreasing order. This is key, non-decreasing order. Return an array of the squares of each number, sorted in non-decreasing order right here. So this is important, and we're giving an array, integer array nums. This is also important, right? So for the first example, you can see they give us this input nums. So they have -4, -1, 0, 3, and 10. And the output is 0, 1, 9, 6, 16, 100. So after squaring it, the array becomes 16, 1, 1, 0, 9, 100. And after sorting it, it becomes 0, 1, 9, 0, 1, 9, 16, 100, right? So, did I say that right? Yeah. Follow up, squaring each element sorted the array is very trivial. This is what I first thought of, just squaring each element and then just sorting it at the end. That would be the time complexity. That would be if we just squared. Let's say we have the array. Let me make that a little smaller. So let's say we have the array, and we square each number. So it would be 16, 1, 0, 9, 100. We can do this with a simple for loop. Just go through each element, and square it. We can do that. And then after we've gone through each element and squared it, we can just do nums sort. Sorry, this is hard to do on this, but yeah, you get the point, right? We'll code it later, but we can just do this, right? We can do this, and this would be, I think this would still be actually, I think this still would be O to the n actually. This wouldn't be O to the, this wouldn't. I think we can do this O to the n, but the thing is, they don't want. I think it would be O to the n squared though, because they're obviously saying. Anyways, they don't want us to do here. -4. What was it again? -4, -1, 0, 10. So this is our example, right? And what we want to do is we want to have a pointer at the left, the very left, so the very beginning of the array. So this would be our left. And we want to have a pointer at the very right, which is our 10. So we would put that right here. This would be our pointers, right? So one at the very beginning of the list and one at the very end of the list, right? And we also want to make a new array. So we also want to make a new array. This new array is going to have the same amount of elements of our input. So we're just going to fill it up with zeros. It's going to be the same amount of our input. So we're going to fill that up with zeros. And what we want to do is we want to compare each. So we want to compare the two pointers and see which one's bigger, right? After we square it. So let's say we have, so for example, right now we have -4 and 10, right? And by the way, for those who don't know, even when you square a negative number, it always becomes a positive, right? So if you square -4, it becomes 16. If you square -1, it becomes just 1. 0 is always going to be last. So if you, whatever the case may be, like even if it's negative, it's just going to end up as a positive, for those who don't know. And okay, so basically let's start with this example. So basically when we're comparing these two pointers, left and right, we see which one's bigger, right? So is the left bigger than the right? In this case, is the left pointer bigger when we square it? Sorry. So let's say, just imagine this was 16 and this is 100. Is the left bigger than the right? It's not, right? So what we want to do is we want to cross that out. We want to before we cross that out, actually, we want to move this 100 to here, right? We want to move this 100 to here. So we move this 100 to the new array, to the end of the list. We move that here. Then we cross it out and we move the pointer to the 3. So this becomes this, and we move it to the 3. And now we check, we go again. This is the squared version. This is 3 squared is 9. Is the left bigger than the right? It is in this case. So what we want to do is we cross this out, we move the point. First off, what we do is we take this 16, which we have here, and we put it at the second last one. So this would be our 16. When I code this, it'll be a lot more simplified and you might understand it a little bit more. Right now I'm just going through a very broad, general, high level explanation of it, right? And so it becomes 16, right? And then we move that, we cross that out and we increment the left, and then the left becomes negative at the second index, the 1 index. So 1 squared is obviously 1. So is the left bigger than the right? No, it's not. 9 is bigger. So then now we put the 9 here and we decrement the right. So we move it here. And we just keep doing it until, so this becomes 0. And then we cross that out, we move that. And then now we're left, now the left and the right are the same. And then this becomes 0, right? So then our new array becomes 16 and 100, right? Sorry if this is a little messy, but this becomes our new array, right? And yeah, that's basically it, the high level view. And you might be asking yourself, how do we add each element, right? So what we're going to do is we're going to have another variable, which is going to be, let's say, our j, and that's going to equal the length of the nums. Actually, I'll code that part. Okay. So now let's get to the coding part. Okay. Let's get to the coding part. So now that we went through a high level view, let's start with our example. So now j, right now we want to have our left pointer. So our left pointer is 0 equals 0. Our right pointer is going to equal length of nums minus 1, right? We're just minusing 1 because length of nums, the index of the first element, starts at 0, right? So we're doing minus 1. And then we're going to have another element, which is j, and I'll tell you why we're doing this later. Length of nums minus, I think, yeah, we'll leave that at that. We'll leave it at length of nums. And okay, so now what we want to do is we want to have a loop. We're going to loop through this. We're going to loop through this list, right? We're going to loop through this. So we're going to do while left is less than or equal to right, because right now left is at 0 and right is at, the left is pointing at the first element of the list, right is pointing at the very last element of the list. Now what we want to do is we want to check to see, does the left element, when squared, is the left element greater than is the left element when squared greater than the right element squared? So what we're going to do is if nums L times 2. I know there's a abs function you could probably use. I've seen that, but I'm just using this because I'm most comfortable with. I use this all the time. Is greater or equal to nums r power of 2. So basically, if this goes through, what we want to do is, since we have j, yeah, we're going to put j minus 1. I'm pretty sure, yeah, j minus 1. So now that we have this, so actually we need a new, sorry, I also forgot something crucial. We're going to need a new list, right? As I said before, we're going to need a new list. So we're going to call it new li equals 0 times the length of our input, which is nums. So if the left pointer is greater than the right one, what we want to do is new list equals, no, we want to do new list j, since j is length of nums minus 1, equals our left pointer, right? So basically what we're saying is whatever element is bigger between these, the left or the right, we want that bigger element to be added into the last element of j, our last element of our new list. And then we're also going to it's going to also be squared. And then we're also going to increment L, right? Because we don't want to use it. Now that we've added that to, now we've added the left element to our new list. We don't want to use it anymore, so we increment it. And now we do the exact opposite of what we just did. So I'll just copy that. And then just put greater. Just do the exact opposite of what you just did. And then we can also copy this one, because why code it? Why write it down again when we already have it? And we just put the right, because now we're saying since the right is bigger, we want j to be our right element. We want, since the right is bigger, we want our new list that we're using in the last index of j to be our new element r. So our old element r. And then also, since we're using r, we want to decrement it, right? So r equals r minus 1. And then after that, you want to do j equals j minus 1, right? So the reason why we're doing j equals j minus 1 is because most likely, and when we're looping through each element, right? When we're looping through -4, -1, 0, 3, 10, whatever it may be, we're always going to add one element. We're always going to add one element to our new list, right? And once we add that element to our new list, we want to go down in reverse order, actually. So if it's going to start from the last, and it's going to go down to the next 0, right? So we want to decrement it to the last 0, if that makes sense. And then now we return new li, right? This is going to be our new list. Oh, we just got an error. Global name. Oh, so new li. I just didn't spell that correctly. Oh, I didn't even spell that here correctly either. I'm gonna have to do that again. Oh, it's nums. What am I doing? Nums. This is the solution. When we run it, let's run the test case. Runs. Let's submit it. See if it works. And yeah, it works. Let me know if you have any questions in the comments down below. And yeah, thanks for watching. Have a good day. Peace.